So now that we've derived this quadratic formula, a formula that we can use to solve any quadratic equation, let's take it out for a spin. I see how it works with some examples. So I want to solve this equation here, and you're welcome to try the methods that we've talked about for factoring quadratic polynomial, but you're going to find this thing doesn't factor. And so if we're going to solve this, we're going to have to come up with some other method, and the formula is going to work nicely here. So the first thing we need to do is pull out those three parameters, a, b, and c. Right? A is going to be the number in front of the x squared, that's 3. B is the number in front of the x, that's another 3. And c is the -1 at the end. So if I substitute those into the formula, we get x equals -3 plus or minus the square root of 3 squared minus 4 times 3 times -1 all over 2 times 3. And this is the real power of this formula. At this point, this is just an arithmetic question, right? If I simplify what's under the square root and simplify that 2 times 3 to 6, under the square root, I got 9 plus 12, that's 21. 21 can't be simplified. The only thing we can rewrite that as is 7 times 3. Neither of those are perfect squares. So this is it, right? Literally 2 steps. And we've got our final answer. Now, one point I do want to emphasize about this, because it's a mistake I see students make. You cannot reduce the 3 and the 6. I'll see students sometimes they want to make this like -1 plus or minus square root of 21 over 3. Doesn't work that way. That -3 is not a factor in the numerator, and only factors can be reduced or canceled. Right, so let's look at another example, and we'll see it's a case where you can reduce, right? So we'll see what that's going to look like. So we'll start off the same way, where we're going to identify the a, b, and c values. A is equal to 1, b is equal to 4, c is equal to -2. So I'm going to put those into my formula. This turns into x equals -4 plus or minus square root of 4 squared minus 4 times 1 times -2. We're going to be really careful with those negative signs in there. All over 2 times 1. So again, now it's arithmetic. Under that square root, we got, what, 16 plus 8. It's going to be 24. And in the bottom, 2 times 1, obviously, that's just 2. All right, now I'm looking at that 24, and I can simplify that 24. Remember, to simplify, I have to be able to rewrite it as a perfect square times some other number. Well, 24, that's 4 times 6. Right? And I know what the square root of 4 is. That's 2. Right? So this is going to become x equals -4 plus or minus 2 times the square root of 6 all over 2. Now, in practice, once we kind of the hang of this, I'm just going to look at that. I'm going to say, look, 2 goes into -4 -2 times. 2 goes into the 2 by the square root of 6 once. It goes away, and I get my answer. Right? But I want to be clear about why we can reduce here where we couldn't in the previous example. So I'm going to go into just a little more detail. Right? I'm going to factor a 2 out of that numerator. It's going to become 2 times -2 plus or minus square root of 6 all over 2. Now, that 2 up in the top, because it's being multiplied by the rest of the expression, that 2 is a factor, and factors can be canceled. Right, so I'm going to cancel that 2 with a 2 in the denominator, and we're going to get our final answer. X equals -2 plus or minus square root of 6. Okay, so I've got one more example for us to look at here, and a couple interesting things are going to happen. First, we cannot just jump right into finding a, b, and c. Before we can start doing anything with any kind of solved polynomial equation, got to set this equal to 0. Right, so I'm going to subtract 5x and add 4 to both sides. This will turn into x squared minus 5x plus 4 equals 0. Excellent. Now I can start looking for a, b, and c. A is going to be 1. B is -5. C is going to be 4. If we drop those into the formula, again, being super careful with the negative sign, especially when you have one on the b parameter. This is x equals -5 plus or minus square root of -5 squared minus 4 times 1 times 4 all over 2 times 1. Now it's just arithmetic. -5, that's plus 5. Under the square root, I got 25 minus 16, that's 9. All over 2, and you see, this is nice, right? The square root of 9, I know what that is. The square root of 9 is just 3. right? So I'm going to replace it, and this becomes x equals 5 plus or minus 3 over 2. And okay, now when this happens, when the square root goes away completely, we're not done. We really have to keep simplifying here. I'm going to split this up into two separate numbers, 5 plus 3 over 2 and 5 minus 3 over 2. And that's what, 8 over 2 and 2 over 2, so x is equal to 4 or 1. So what happened here? Well, if you look back at that original x squared minus 5x plus 4, that thing factors. Right? When I see this happen, right, when the square goes away and it becomes an integer, that's a sign to me, yeah, okay, I could have factored that thing if I'd looked a little more carefully. In this case, it would have been x minus 4 times x minus 1. But it don't matter. Right? This is really the glory of the quadratic formula. It works. Right? It works in every possible situation you can come up with a quadratic equation. Okay, so I picked the numbers here carefully. I picked all of those coefficients to make sure that the discriminant, that's the number under the square root, I picked them to make sure the discriminant was always positive. What happens if it's negative? Well, if it's negative, yeah, that's okay. Formula absolutely still works. We're just going to get a complex number. We're going to get something with an I in it for our solutions, and that's what we're going to look at in the next lecture.